live, right, Matteo?
Yes,
I
we
don't know. Let's
are.
check.
Hi, everybody. How are you doing today? Hello.
Sorry for the delay. Technology definitely sometimes is an obstacle more than an accelerator. And when you are talking about streaming, well, that's why you're all here today to talk about the problem with WebSockets. So I
Yes.
think you're all at the
So
right
you, so you,
time
you,
at the right place.
we all know you are old school, Luca, because you always talk about pens. Okay, so you know that it's
They're not old school.
I'm joking.
I
Okay.
think I think they're so beautiful. But today we are talking about WebSockets,
WebSockets,
right?
and the problem
Um,
of WebSockets. You know why I got interested a lot in WebSockets, Luca? Did I ever tell you?
no, no.
Oh, wow. So this starts when I was doing my PhD back in um, 2011, 2012, 2013, and so on and so forth. And I was at the University of Bologna, and I was doing my research on the Internet of Things and how to connect devices. Okay. Now, one of the problem if you want to connect devices is the display of data and delivering meaningful data to the humans as quickly as possible. Okay. Now these because these usually involve the use of some WebSocket technology. Okay, and how we can make sure that data that is produced from data that is collected from your sensors outside, your temperature sensor or maybe your power consumption sensor and so on and so forth, is taken and reported to you as these things is captured. Or in other words, putting it in another way, let's say that if you have a movement sensor, okay, you damn want to know at the moment that is tripped and not every in 30 or 60, in 30 seconds or 1 minute. Okay, as a human being, this is a hard requirement. When this is where WebSocket is great for. Okay, in general, but also everything comes from that type of system. So you have data that happens right now and you want it delivered to the end user, okay, as quickly as possible without delays.
First time I used WebSocket was to build a chat.
As everybody does.
Probably the
As
easiest case
everybody.
study. And then it's kind of funny that I met again with WebSockets back in, well, we built at the time a lot of stuff for doing real-time communication and so on between system when we were building the first ever service mesh. But anyhow, I personally came back to have to write WebSockets in 2016 when I got an offer from Netflix and they sent me an assignment. And it was actually a very cool problem to solve. But at the same time, you find that a technology that fundamentally you used before to do a chat, then is used also for something else, then is used to do recommendations, then is used to do other things. So that's actually, I think, the beauty. But at the end of the day, it's just a transport, right? It's nothing
Yes.
esoterical. Um, well, and I think today we have the so-called maestro of sockets and streams in Node. So I think we have the right person to debunk any sort of myth or to answer to any
Wow.
hard question. Um, and recently, you and I were actually talking with one of our customers that is apparently using a lot of WebSockets to
WebSocket.
build a
WebSockets
dashboard.
WebSocket everywhere.
Well,
WebSockets are everywhere.
let's start from the hipster thing of nowadays, like subscriptions, because nowadays we talk about
Let's let
WebSockets, like,
Yeah, but
like,
okay. Um so subscription, when Luca talked about subscription, guys, it's about GraphQL subscriptions. Okay.
yeah, clearly I said also hipster before, so it was for sure GraphQL. I
So
mean,
GraphQL subscriptions are great, okay, in the sense of it's a good transport over WebSocket, okay, that doesn't add absolutely anything on top of WebSocket, minus the format of GraphQL and how you make queries using the GraphQL languages. However, it has a few limitations. We can go through the limitations in detail. If you want to. If you want to do, we can do it.
No, I just wanted to start saying that nowadays the you know, if you want to be cool, use GraphQL subscription, but the old time.
No, if you want to be cool, you use MQTT over WebSockets.
MQTT over WebSocket.
Yes, yes, it does, and it does work very well. I did my research 10 years ago, so
yeah, exactly. It's not hipster. That's vintage.
It's super vintage. It's super vintage, but it's perfect. Okay, I love vintage things, so I built a full system, a modern system built on top of tar. The file format, and there's no file format for tar. Like there's variations of it. So,
but I mean, I think everyone is here to learn something about WebSocket. So let's maybe take everyone on a journey with us.
Let's take them on a journey. Okay. Would you mind if I share our little bit of a Scalidro thingy, Luca?
Yeah. Let's not make it a whiteboard session, or else it's going to be boring. Let's make it.
Are we sure?
Yeah.
Come on, it will be fun. Okay. So let me try that, and then I can remove it soon. I think on a whiteboard session, we can try doing a whiteboard session. Guys that you're watching, would you like us to draw some architecture live in one of the few new session? Please let us know. We are looking for topics for future shows.
Everyone is looking to get architecture. Come on, that's a tricky question.
I know. But it's
that's like asking to a kid, do you want candies?
Okay, so let me get a user. Where I get a user? Do I have a user? Okay, anyhow. I do have a browser. Used to have a browser here somewhere. Okay, I have a browser. Here we go. We have your browser. Okay. Now, this is your browser. So the typical thing of a WebSocket is you have a browser. Okay. And ooh, this is interesting. Okay. No, I don't want anything here. And you have your server. Okay. All of this is good. So this guy creates WebSocket. Okay. And the return is message or on message because it's such a fancy API. Okay. Does it make sense? Now,
well, sorry, it has to be an event, right? It cannot be a single message.
Well, yeah, it's more than one. Yeah, 1, 2. Okay. Does it make sense?
Yeah.
Okay. So we have something here. Okay. Now, what is the problem in this system? And all of this is said and good, and it makes everything super easy to understand. So I don't think that nobody will do an hour talk, an hour discussion about this if it wasn't something more. Okay. Now, the problem comes because in reality, this is what's happening. Okay. But in reality, okay, what you want is, okay, let me put it over here. Okay. This is another server. Okay. And let's call it another server. Okay. Somebody else does a post for some data, and the key question is how you get this. So how from this server you get this other server to send the messages to be forwarded. This is the hardest problem. This is why WebSocket is freaking hard. You need this kind of scalability because you cannot do that. You cannot take your post on the main server. You need to pass through another one, mostly because if you go to only one server, if one goes down, you lose everything. And at some point, these things will crack. Typically, these can crack at, I don't know, if you're good, 100,000. If you're not good, some thousands. So.
What do you mean with 100,000 and 1,000?
At 100,000 connections.
Yeah.
Okay, 100,000 connection and 1,000
concurrent, right?
Concurrent. Okay. And we are not talking about other problems like redelivery of messages and a bunch of other stuff, which is...
And just to clarify, the size of the message doesn't matter in that case.
No, it doesn't matter at all. Well, it matters on how many you can attach. So yes, it matters. It matters on how many you can attach, typically because the bigger the messages are, the more frequent. So you know, the biggest, the more frequent. It's the lower it's the biggest the messages, the more frequent they are, the maximum amount of connection that they need to be sent to. All impact the network stack of the server. Okay. Now this is probably, I described this a little bit, we'll share it again. So let's talk a little bit about the network stack of the server. Because somebody completely forget about this. Do you know how much this is important in WebSockets, Luca?
Well, in any system, right? Because you are going through a beautiful cable.
Exactly. And a lot of people completely forget that there is a frigging cable and a frigging operating system. So now imagine that you want to connect 100,000 connections. Okay. Idle, you are sending some messages every now and then, but you have 100,000 there. Okay. Now, you think, oh, I have a tiny object on my node process. How big would that be? Okay, maybe, I don't know, 100 bytes, 200 bytes. Okay, fine, easy. Wait, because it's not, okay? Because it's attached to a socket, okay? And the socket has some buffers, okay? For sending and receiving data is TCP. Okay, it's a TCP socket. So it has some buffer for sending and receiving data. Okay. Now, this is a lot of things a lot of people would completely forget when dealing with high level and web stuff, but it all comes from the lower hand. Like how we talk about memory management and memory leaks, you need to understand how a heap work, how memory work, how memory is allocated. What is, an allocator? I don't know, this kind of stuff. Anyhow, the socket, okay, what you get, every time you receive a socket, or you create a socket a TCP socket to talk to a different endpoint, or you receive a socket as a server, some little bit of data is allocated. Okay. What is, because you need to receive the data, because the messages can come out of order, right? You remember TCP that allows, out of order and so on and so forth, and you reassemble them and then deliver to the user in order. Okay, that's great, but there's a memory cost. Okay, so let's say that you want 100,000 objects and you need to multiply them by 16 kilobytes and 16 kilobytes. So essentially 32 kilobytes for both buffer, one sending down and other sending.
But you're considering a duplex, right, in this case?
Yes, yes. We are talking about, do you know how much we are talking? 100,000 concurrent connections? Okay. 3.2 gigabytes of server memory. That's a lot, okay? It's a lot of memory just there to receive data. Okay, now there you can tune the system. Okay, and instead of doing all of that, you can lower it to 8 kilobyte. Okay, and these will bring it down to 100 megabytes. Okay, but then it means that you can only
the frequency is higher, right? Because you need to create more chunks.
You will create more chunks to send to the TCP socket, and essentially lowering down the overall throughput for each individual socket.
Correct.
So it's, and it is the funny part about this, even worse. And this is what I've seen a lot of people struggling with WebSockets, okay? It's, these settings, this memory is not in your app. It's in the operating system.
Yeah.
Of your virtual machine, of your virtual machine. So you need to configure that, okay? and tune it to support this. And a lot of operating system limit the amount of overall memory that can be used for a process of network memory to, I don't know, 200 megabytes, 300 megabytes, and which means you can just, when I say you are good, you can go to 100,000, okay, now without too much problem, okay, but you need to be good. You need to know that you need to tune the kernel, you need to know you need to tune all these settings, you need to make sure everything is correct and work fine.
And imagine in the cloud when you're on EC2 and you don't have, for example, control over.
You do, actually.
Well, yeah, sure, but
on EC2 you do.
Yeah, but not. I mean, you need to. How you say? You need to tune anyhow the machine. You cannot actually go
on the machine, but you can do it on EC2. Okay. The true moment where it's good luck. Okay. It's I want to do it on something like a pass. Okay. Or good luck if you want to do it, for example, on Kubernetes. Okay. By the way, it's possible to do that in Kubernetes.
In Kubernetes, you can do it. It's not. You cannot do it when you are, for example, in probably in Fargate.
Yes,
but,
in Fargate you can't. In Kubernetes you can. Okay, yeah. But it's a lot of work. Okay, it's a lot of. You need to think about all these things and do this tuning at the kernel level. And a lot of people who say, "Oh, but I don't want to do tuning at the kernel level." I said, "Well, then you're screwed."
Okay? Well, you lose actually support on the Amazon Linux, right? So because Amazon Linux, if you boot the standard image,
no, you can with a standard image. Okay, you can specify certain boot parameters, and in those boot parameters you can change those things.
Can you in the
LI? I remember that we did it. I don't remember the details.
Because I thought it was actually only when you use your own custom image to do it.
No, because they are on the parameters that you can put in at the top.
Because I think you can only change the throughput of the network card. If I'm not wrong.
It's you can pass down some kernel settings, and those are kernel settings that are.
Oh, good to know.
But anyway, this is like you need, in order to arrive that is the problem. It requires such a huge gap from I want to build a chat, okay, or I want to display something very quickly on my browser. That is
but I mean, I think where it gets actually the clash is that you lose some of the reliability that you get out of the box with using pre-baked images or like the standard images. But I think apart from the throughput, which is kind of like the first bottleneck, for me at least, it was actually interesting the first time I had to think about reconnection, because that's actually I think a fun problem. I mean, a fun problem probably when you are, thinking it the first ever time. Nowadays should be an out of the box thing, but
it's not, Luca.
We actually face the reality that
it's not.
It's not.
It's not. Okay, so let me tell you a very nice story. Okay, how MQTT.js works. Okay, how MQTT works, because MQTT is a small protocol that everybody can study, and it was. Let me get the year, actually. It was standardized. It was started for the first time in 1999, okay? And it's a binary protocol, very easy to read, very easy to implement, to be honest. So everybody can take a look, okay? And thank you, Wendy, for this. It was great, okay? So MQTT supports the concept of quality of service agreements. And you can, when creating a subscription, not that I'm with a subscription, I want to receive data, okay? The client tells the service, look, give me a quality of service 0, 1, or 2. 0 is best effort, okay? If I disconnect, if I miss some messages,
good luck.
Good luck. I don't care, okay? Quality of service 1, okay, is at least once, okay? So messages will be retried by the sender multiple times, okay? until the receiver acknowledges its delivery. This is very important, okay? And it works across reconnections. So if my message is, if my client disconnects and reconnects, okay, the protocol defines how all of the dance between the client and the server to make sure that the messages are resent. It's very simple, okay? For each client, the server, the broker, maintains a list of the messages that have been sent but not acknowledged. When that client reconnects and this message is not acknowledged, it sends back, okay, the client. It sends the message back, okay? Easy. Now, there is also the exactly once delivery. But what will ensure this? These will ensure that the client can receive a message more than once, okay?
Correct.
However, there is also the thing called quality of service 2, or exactly once deliver, okay? Which does a 2-level handshake, okay? So the client acknowledges the acknowledgement, essentially.
Yeah, which is the kind of like a strong consistency between sender and receiver.
It's a strong consistency between sender and receiver, okay? You can see all of these more or less as variation on the CAP theorem, to be honest, okay? But it's all about distributed systems and so on and so forth. Going back to the problem of WebSockets, okay? You want to deliver something from an update from the server to the front end, okay? Now, the problem there is, what if the connection goes down? Now, you need to implement these kind of queues and systems behind the scene that buffer the data and reconstruct the data for you, okay? If that's what you want, okay? In all of this, GraphQL subscriptions are lacking this capability. They only offer a best effort type of system, and therefore, problems be there. Or in other terms, if you want quality of service 1, you need to implement it on your own on top of it. Okay, it's fine, it's doable, 100%, but it's more stuff that needs to happen.
Yeah, because the reality of facts is that you will never stream, like you were showing earlier, data that you already have in memory. Like, it's not that you are the producer and the broadcaster of that data, right? You're gonna take data from somewhere else, usually in a more reliable architecture. Imagine, like in your sketch, you had a service where people can post new data, and then somehow the read service in a CQRS kind of like fashion needs to actually provide the reading capability to the different clients. So following your line of thought, if I need to reconnect and I'm depending on a third-party system, it means that I need to some sort like keep a session cursor. I need to kind of like being able to understand where each client left the connection before the drop and retake it from there, right? So if you're looking at, for example, this kind of like stream of data, you will have people starting to ingest over and over data, and people reading that say, oh, I drop at pointer 16 and I need to retake my stream from pointer 16 while the pointer move, for example, to 100. So that's kind of like the common use case. But recently we have been facing this issue with one of our customers that kind of like we're trying to solve this problem at scale. And I think, for everyone listening to our chat today, it's interesting to kind of like go through our train of thoughts on how to solve that problem. So imagine the common problem of having, like Matteo was saying, a dashboard with n type of non-deterministic consumers that they can join the stream at any point in time, and I can drop it, I can restart it, and having an infinite flow of data that comes on the other side. I hope Netflix is not actually using this test for their people anymore, or else we just destroyed
Luca, you should have not
test.
tell that.
well, too bad. I mean, it's already it's already like 2016, so it's 9 years ago. I hope they changed the test.
I wouldn't have changed the test.
But it was so lame. Like, well, for everyone. So in case you're applying for a job, Netflix, one of the questions they might ask is to build a system that takes an infinite amount. Well, infinite means a continuous stream of data to process in the UI the number of stars associated with a certain movie. Which, if you think the problem can be solved in a million ways, right?
Infinite ways, Luca.
Like, no, I think you reach a point where basically you're just like hitting the wall. But for example, I tell you, I solved it at the time. I use RxJS to solve it. I use a reactive extension to do it because I thought it was a cool new way to approach this problem.
Yes, Luca, among all the possible things. Did I ever taught you anything about JavaScript? Probably we didn't interact too much.
Why? RxJS is phenomenal. I mean, I personally thought that the DSL was brilliant.
It's one of the slowest possible things that you can use in JavaScript.
Yeah, but I mean, I think my stupid thing was processing more than 100,000 request and data stream. I was creating like a million of data points with a synthetic generator. So they were working not bad, but that's not the point. RxJS is dead, I think. I don't think it's maintained anymore. I don't know. I'm blah blind, but with WebSocket, that's actually a very, very cool problem to solve. Like, I think we are going back to first principles of architecture of real-time distributed systems.
Yep.
Where distribution means 3 points, but still interesting. So let's try to solve. We have 20 minutes. Why don't we solve the Netflix challenge for everyone? So for everyone joining the WebSocket,
no, Luca, we can't spoil this much.
9 years is already online, by the way. So
it's already online. If it's online, it's fine.
Everyone has this challenge. You and I even hire people using this question. So that's
Luca, don't.
But I mean, we don't say Netflix. We say you have a system that gets non-deterministic continuous flow of data, needs to be processed to generate some sort of like output that is a number that goes from 1 to 5, number of stars, and be shown by a UI. So one thing that I actually didn't do, and they asked me to do there, was what if I close the browser and reopen the browser? Does it make sense to reconnect, or in that use case doesn't make sense because it's an average anyhow? So anyhow, it's processed behind the scene, is an average, doesn't matter, right?
It always doesn't matter.
But it's not true. But if you're building, for example, a dashboard to show like statistics or like values,
it totally
that
matters,
right? So
that matters.
That's the thing.
Yes.
So let's pick the example of a dashboard. So we go away from the last part of the Netflix question. We still give you the first two. The last one is on your own. But you're building a dashboard where data must be consistent, which means that if I, for example, drop in this moment and I reopen it, I clearly don't want to see a gap in time in my graph of, for example, memory usage. Let's pick an example.
Absolutely.
Right. So let's take advantage of the maestro and start from the reconnection problem. So, and then we go back to how the data is pumped into the system.
Yes. So, okay. So the biggest, going back to my little diagram that I know would come useful, okay, because it always comes useful. That is the core problem of WebSockets. So here we go. Okay, it's the core problem of WebSockets. So messages to be forwarded. Okay, now the problem here, if we want to handle reconnection, okay, and by the way, you need to assume that a WebSocket will go down anytime. Okay, let me repeat this. Let it repeat it together. Put it on the dashboard, on the dashboard, on the dashboard with a chalk like Bart.
On the blackboard.
On the blackboard, yes, the blackboard like Bart. Okay, I will not assume that my WebSocket are stable. Okay, your WebSocket will go down, and you need to design your system so that your WebSocket will go down at any given time. If you're not doing that, you are setting yourself up for a world of trouble. So don't. Okay. So looking at this is actually quite neat. You have your WebSockets. The problem is in here. Okay. Now, what you want to do. So let's copy this thing up. Okay. Here we go. And then paste it down. So we have this thing. Okay. Now, the messages. So first of all, we need to. What is it? We need a database. Okay, we have a database. Okay, so you have a database with typically that contains. No, what did I put? Okay, wrong. Historical data. Okay, so you have. Let's put it that you have a system that contains historical data. Okay, here. And then you have a nice little thingy, okay, that is a queue that contains live data. Okay, live data is only live, right? So if you want to reconnect, okay, let's say you are the browser, okay, here, and you receive 1, then 2, then 3, you want to receive all those messages, right?
Mm-hmm.
Okay. Now, at some point you have, and okay, so you receive 1, it goes down, right? Now it arrives here, then here we have a disconnection. Okay. And so far we have received 3 messages from the top. Okay. The browser wants to see 4, 5, 6, 7. Okay. But it can't, it disconnected. Now the browser will connect back here. Mm-hmm. Will connect back when this is reality. Okay. And however, or let's put the green. Okay. So if it reconnects when at this point, okay, it will lose these two messages. Okay. So in reality, what it needs to happen, okay, is, let's copy this up, okay, is something like this. It reconnects and then it's a gap, okay? So you have this is the stream of messages. Okay. And what you get instead is you need to implement this kind of little bit of delay. Okay. So this means that you need to tell when you reconnect, okay, you just not open your WebSocket, okay? You do something like new WebSocket, and then you do, I need here, okay, ws.send last message ID. Okay. So when you reconnect, you send back the last message ID that you have seen. Okay. In this way, you have implemented, okay, this is at least once semantic. QS1 in MQTT lingo, okay? Which I think it's the only thing, this the cheap thing to do. So you should be doing this system, okay? And you need to implement this every single time. And then it needs to resume. So going back to our architecture diagram, okay? So here it's sending the last message, okay? So for some data, it needs to get this from this guy, okay? Then, after a while, from this guy, okay? Okay. Sorry. Last message ID under current ID. At connection time. And here is afterwards. Now, this is hard, okay? It's hard to do. And this is why a lot of people will say don't do WebSockets. And frankly, I can absolutely, why this is, okay. Okay, fine.
Yeah, but without actually, basically, how would you actually fill the gap between those messages? So how do you pump them in a way that the user, would you actually get the user to basically kind of like restart from point 3 and then continue?
Yes, the user will send here with the message, last message ID 3, essentially. And then the server knows that the last message it had received from the live data queue is essentially 7, okay? And it will fetch all the messages from the historical data source.
And you're gonna basically compose that message. How would you actually do it?
Oh, it's just messages that I'm putting down in sending them normally.
So you would basically go back and say 3, 4, 5 from the database, 6, 7, or
exactly
5 or 6, and then 7 from the queue, 8, 9, and then pick up the stream again from there.
Exactly.
But how would you actually? Okay, and that's also a scalable solution because the server itself is still stateless, right?
Yes, in this way, the server is stateless, okay? It does not maintain any conception about that WebSocket, specific socket, about the state of that server. So you don't need to use like, I don't get the term in English, the pinned connections. I don't know, but there's a specific term.
The sticky connection,
yes. The sticky connections in your load balancer, for example, okay? You can avoid all of that, okay? Don't need to, it's fine, okay? No need for sticky connections, okay? Everything can be stopped and restarted as many times as you want. And even if the socket goes down, your browser can reconnect, pass the last message, and it will reconnect all the time. This works perfectly.
Okay? So you basically kind of like have a handshake model with a cursor-based, index-based approach. And you say, if I pass an index, that's the start index.
Yes. Absolutely.
There is a question actually, kind of interesting. Sorry if I sometimes turn, but we have the question that everyone is asking on the side and not on the main screen. Is it possible to scale WebSocket without a queue, like a video game, Fortnite?
Okay, so this goes into the point where you let's remove this thing. Okay, so we were talking about the case where we don't want to lose a message. Okay, now a video game, okay, is very important to know. A video game do not require, okay, do not require to not lose messages. Okay, a message, it's not if it's lost, if it's not received in a reasonable amount of time, okay, it's useless. Now you are playing your Fortnite and you shoot, okay. Now if your connection drop, okay, it doesn't. You want to hit the person on the other end, but if your connection drop, nobody cares, okay. If the connection of the other guy dropped and gets stuck, okay, or you drop and you don't see them moving again, those messages are completely useless now, okay. So typically, soft real-time system attach, say work can also work and say if a message is not important, then who cares? Okay, I'm losing them. Connection drop, reconnecting, it's fine. Okay. Now, this is also the reason why for a lot of this kind of real-time thingy, sometimes UDP is used, and why a lot of other people talk about, I don't know, Quick as the future of web for those kind of reasons, Quick, HTTP3, and all those kind of things, because they are based on UDP and therefore can allow for a much better, finer control on this kind of situation. Okay. But generically, I would say it's you want to lose. We want to lose. You want to lose. You want to lose data when you're playing video games in like that. You never want to lose data, but if you lose it, it's not important. Okay, it's gone. Okay.
Well,
if
you
I
can
can
still.
shoot the guy on the other side, it's useless. That data chunk. So.
Well, you actually still have the kill though.
Well, yes. Maybe.
So it's not maybe. It's actually the way. I mean, first of all, the way video games are built, they are not as the architecture we are showing. We are talking about like massive scale systems. The message, in fact, in video games you have also the terms lag, because the lag, so the distance between messages received and the lag of your processing those messages is important. But let's say video games are not just like a simple web chat. Let's be kind of like clear. Also, the infrastructure behind video games is completely massively different. By the way, I don't know if I ever told you. It doesn't.
What?
It's a completely off topic. But when I was working at TELUS, I had the chance of. I come from the video game, so to see a very large gaming company running on GCP, and they were the largest users in the world of Bigtable.
Wow.
And also the largest of their kind of like key value storage. And I was extremely impressed on how basically they were using the key value store to process the real-time data between players. Because it was, to me, was kind of like amazing coming to see how Blizzard kind of like build it versus this company. It was actually kind of amazing. So that's probably another.
So there is a message in the chat. At what time do we stop using WebSockets for chat application? And my answer is never. You will still need to use WebSockets. It's just what you build behind it to support the chat app and make sure the messages are actually delivered.
But what's the difference then between a WebSocket and making a set timeout on a second?
There is absolutely no difference between the two. Minus. No, there is one difference. Okay, and this is a difference where it matters to you if you build a scalable system like the one we described. Okay, there is a difference. Okay, the set timeout create way more traffic for you than the WebSockets. So generically, you want to maintain those WebSockets, okay, so that you know who is online and who is offline, okay? Otherwise, you will need to keep maintaining that map based on, oh, is it calling me every second, okay? Which you can absolutely do like that.
But still, the WebSocket would require that for the online-offline, right?
Sorry, no. You will know that the socket is active and it's fine. You don't need the ping pong. The ping pong socket does it on its own.
Yeah, no, sure. But the only difference is that for the is alive, I need to make a continuously call. Is alive, right? And it is a two-way, so I need to also call back. The WebSocket, I know constantly that something is online because the connection is open.
Exactly.
So that's,
there is another good question. In which case should you choose between WebSocket and server-sent events? Okay. The only difference between WebSockets and server-sent events. So if you don't know server-sent event, they are the poor man WebSockets. Okay, they are fantastic. Okay, two major things. Okay, WebSockets are bi-directional. Okay, So the client can send data. Okay, so this is great. Okay, so you can have bi-directional communication. With server-side events, you can't. You need to have the bi-directional, okay, from doing posts and gets as REST. Now, that can be okay in a lot of situations, and all the things that we talked about scaling
a dashboard or so
is the same. It's the same concept, okay? It doesn't matter, okay? Everything is the same, okay? Minus the fact that you have way less control on, ordering of messages, calls, and so on and so forth. So you don't know, essentially, what you will not be able to track if you receive an action from the same user, okay? You will be way harder for you to order them logically.
Yeah.
Because you receive a post, but you don't know if that post was delayed for whatever reason on the network. So if you send 3 posts, they can arrive to you in all possible orders because of network constraints. Okay, no clue.
But
okay?
Because they're not queued in a single
exactly.
socket.
While if you put on the same message on the same socket, they will be queued. So
yeah, that's the only guarantee we have is the order of things.
Yes, well, it came from TCP, and that you will have the same guarantee also on HTTP3, by the way. Loving it.
But, I mean, you could theoretically achieve the same thing because AWS basically does similar thing with SNS, right? They're all they communicate through a more kind of like logical way of server-side event, but you should then, in case you want to use it to guarantee the order of messages, you need to always exchange the epoch of the request.
Yeah, you probably need. Yeah, it's way more complicated. The time problem. It's very hard to guarantee that. Let's leave it at that, Luca.
And plus, because
I don't want to go into atomic clocks. So
exactly.
This is a long conversation of atomic clocks. I can't wait to go into Lamport. Okay, it's not the correct. Like we should do a show on Lamport. Okay, but it should not. We should not talk about Lamport right now because we are almost on time. We started late, so we'll probably.
And in case you're interested in the Lamport, let us know, because if you are applying for a job at Uber, that's their question, by the way.
Lamport. Paxos.
No,
Lamport.
atomic clocks. The question that they always ask, and it's not a secret, so I'm not revealing.
Yeah, but most people don't know. Like it's done now, okay? And they never read the spanner paper from Google too.
No, but what is actually, I think is what is actually interesting about that problem, the question that Uber usually asks, is about the chaotic system, so non-deterministic chaotic system, and they kind of like what I think is super interesting, which relates to also. No, I ask a question because that was also in the Uber. When you order a Uber and you see the car going on the map, from the moment you order it, right? And dispatch gives you the car. How do they scale those WebSockets, given that there are millions of people concurrently accessing
I know how I would scale them. I don't know how you would scale them, but I have a good idea of how I will do it.
30 seconds. How would you scale it? And then we take it to another time where we talk about the distributed system and atomic clocks.
I would use, given that it's all ephemeral, okay, we don't need to store any of that. I would probably use a consistent hashing and redirect both to the same single server. And that system can actually scale to millions very easily. Okay, without maintaining any sort of central architecture, making this super great. And I think it's probably how they implemented it, to be honest.
That was the first implementation. Then with K8s, they actually went into this long, persistent session, and you subscribe to a session. So the session is global, and then that's how they kind of like scale it on, basically. But behind the scenes,
it's the same. It's underneath.
Behind the scene is a consistent hashing, because that's the only way you can scale the state. But the system that they used before, you were connecting with the channel straight into.
But I'm talking about the high level pattern. No,
So it's a hash ring all the way. If you consider that, I mean, every sort of system with state uses two patterns. So, and it can be the topic of another time. How you
Oh
would
yeah,
build
well
a
we can the
distributed
topic.
states
You know,
system.
it's a good one.
But we are at time for today, and we are 1 minute late. Sorry for us to be late. And Matteo, you already asked everyone to always give us new topic.
Yes, we need new topics, guys.
But
new topics, more topics.
We
more
have
topics
something
and
in
newer
mind
topics.
For next week.
Okay.
Everyone will get it, but it's a cool topic, I think. It's a mix of what we discussed in the past few times put all together. Let's see if that people like it. Or else you send us a suggestion and we're going to talk. We can, Matteo and I love to jam, so it's not an issue. Yeah, I think for today we had our chat. It was a little bit short because of a technology impediment, but we made it through. I hope you all enjoyed this conversation. Any question you might have, send it to us. And as always, we'll see each other next week. And if you have anything to add, any comment, always well received. Till then, what we say. Ciao, everyone.
Ciao. Ciao,
Bye-bye.
ciao, guys.